Hello, Math 20-1. This is where the math really hits the fan with rational expressions. So you're going to look at a selection of a couple of different applications for rational equations. The important thing here is this is just a methodology, okay? And because of that, I want you to work at understanding the methodology, not to memorize this particular question, because there's many questions in terms of mixtures um, and other situations where a rational equation will be involved. So what we're practicing is not so much memorizing this particular question so that you can do it on the test, but well, how do I come up with rational types of equations given the context that we're talking about? So the first one isn't really earth-shattering. To be honest, it's a good little entry and says, well, find the value of two integers, one positive integer that's 5 more than the other when the reciprocal of the larger number is subtracted from the reciprocal of the smaller. Blah, blah, blah. Now I know this is not going to save world hunger, and it's not going to be a cure for cancer. But what it is going to do is test our ability to underline and read. So what are we looking for? We're looking for two integers. One of them is positive, and it's 5 more than the other number. Okay, that's cool. This idea of reciprocal, I think I know what that means. And the larger number is subtracted from the reciprocal of the smaller. Okay, so we need to put that into an equation that we can solve. Okay, so generally in most of these questions, the first thing you need to know is, what are we looking for? What are we looking for? Okay, and when you decide what you're looking for, that's usually in the stem of the question, the first thing. We're looking for a couple of integers, okay? We're looking for the value of two integers, and one of them is larger and one of them is smaller. So the first thing you do is you write some let statements, and they have to be meaningful, okay? So what am I looking for? Well, make a let statement. Let x equal the smaller number, and therefore x plus 5 equals the larger. And there's not one person in our class that cannot do that. That's what I'm looking for. Check. I've done that. I've got 1 mark. I'm on the road to solving this question. Every single question, write a let statement. It's not an optional thing. What are you looking for? I know what I'm looking for. I'm looking for two integers. One of them's x, one of them's x plus 5. Now, the second part comes in reading this equation and reading this sentence and saying, can I make an equation out of what it's saying here? I think I can. It's saying when the reciprocal of the larger, okay, well, what is that? I already said in my let statement the larger was x plus 5. When the reciprocal of the larger, 1 over x plus 5, okay, I took the reciprocal of the larger, is subtracted from the reciprocal of the smaller. Okay, so that's subtracted from the reciprocal of the smaller. So the smaller one is 1 over x. 1 over x minus 1 over x plus 5 is equal to 5 over 14. Check. I've got an equation. Okay, so what are the steps? First step, make a let statement. What are you looking for? Second step, I got an equation. Guess what the next step should be? I think we need to solve, right? So step 1, step 2, and now we solve based on the skills we learned in 7.5. So I know my lowest common denominator is 14 and x plus 5. I multiply every term by that, x and x plus 5 and 14 and x plus 5 and 14 and x plus 5 and 14. I blow stuff up. X plus 5 and x plus 5 and 14 and 14, and now I'm just going to zoom ahead and simplify it to save some time. Okay, folks, because we've spent all that good work in 7.5, I've zoomed ahead and solved this equation. So when you look, I found the lowest common denominator, and when I multiplied by it and blew up all the denominators, I got this equation right here, which then I took it all to one side and got this, which then I divided by 5, right? This is an equation, so I don't have to factor it all the time. I can divide everything by 5. So I did, and I got x squared plus 5x minus 14, which now I factored, which now I got 2 answers. But that's not the final answer, because the question said, what are the two numbers? Well, therefore, if x equals 7, then my numbers, right? Remember what x was. X was my smaller number. So if x is one number, then my numbers here are 7 and 12 because x is the smaller number. If x equals -2, then therefore my numbers are, well, if the smaller number is -2, then the bigger number is +3 because I just add 5 to get the other number. And both of those situations should work, but we should probably check it out, okay? All right, so that's not going to save world hunger, but that is definitely a start into the steps you need. So remember, look for what you're trying to find. Write a let statement. Second step, read, find an equation. Third step, do what you did in 7.5, solve it, and then find the answers and check to see if they both work out, okay? Moving on to the next example. So in the next example, we have a traveling salesman, and you have a chart. So again, you read carefully, and you tell yourself, what is it that I'm looking for here? In this case, we're looking for, it tells you right here, at what rate is the salesperson traveling? Well, this salesperson is traveling at a rate of R. We're looking for it. Let R be the rate of travel speed in miles per hour. Don't forget, distance equals speed times time. And I know in physics, Mr. Teskey might have shown you something like this. Distance equals speed times time. And that way you can use this formula any way you want. That means time is distance over speed, and speed is distance divided by time, and distance is speed times time. In the different ways you can manipulate that formula, okay? So now we go to the chart. And you can always build the chart in this situation, but it's kind of handy because you need to ponder distance, speed, and time. So the trip to the client, well, how far did they go? Well, we know he went 150. We know he went at a speed of R, making his time 150 divided by R. If only we knew what this speed was. On his way home, he drives a little bit slower because he's smelling the roses along the way, and he's just having a good time, right? So obviously his time is going to be 150 divided by his new speed of R minus 10. So this is consolidating information and putting it together, and now what do we do with it? Well, we need to find an equation, and we have that in this sentence right here. On his way home, he drives this much slower and adds 1/2 an hour to his driving time. So these two times are not equal. They're not. However, they're a 1/2 hour apart. So the longer time minus the shorter time gives you a time difference. And what's tricky is, I know he's got more speed here, but more speed means shorter time. So you need to subtract this bigger time from this smaller time. So this is really about a time balance. And in these questions, you need to be careful when you're thinking about which one of these expressions is bigger in time, right? More speed, less time. This number here is smaller, okay? And so therefore you subtract in that way. So this minus this is 1/2, and Bob's your uncle, you're off to the races. This now becomes 7/5. The hardest part is done. So what have we done? We've defined our variable. Don't forget, we filled it in on the chart, and now we have an equation. Off we go with our skills in solving equations. So this is on the next slide. So my lowest common denominator is 2R and R minus 10. I multiply all the terms by it. I get a beautiful equation. I factor it. Nothing really new here, but now we get two answers, 60 and minus 50. Do we accept this one? Do we not? Why is it not acceptable? I guess that's a leading question. Well, when you think about it, it does not make sense to have a negative speed. The context of that doesn't make sense, right? So the salesman must have been driving home to the client store at 60 miles per hour. We can check this answer by plugging it in. Yay! And we can see that on his way there, it took 2.5 hours. On his way back, he takes 3. So it does work out to be a 1/2 hour longer. The check works. All right, in the next example, there's different ways of um, using rates. This doesn't have to always be speed and distance and so on. Here's another way of using that same concept. But in this case, we're looking for the time it takes to paint the room together. So obviously you've got a professional who takes 4 hours and the assistant can take 6. What if they work together? How long would it take them? Would you take the average? What would you do? Well, it's not quite that simple, but if you think of rate of work as speed, so the only thing I'm going to do here is put a unit. This is amount of room per hour. So amount of room per hour. So kind of like kilometers per hour, this is the amount of room per hour. And then time worked is obviously the amount of time that they were painting, and then the portion of the job that was completed. Okay, so if we think of what are we looking for? Let T be the time it takes to paint the room together. Okay, cool. So they worked for T hours. We have no idea what that is. The rate of work they can get done in an hour, the rate of a room per hour, well, the painter gets done a quarter of a room in an hour, right? Because it takes him 4 hours to do it. An assistant gets 1/6 done in an hour. So after T hours, how much did he finish? Well, I guess if T was 6, he'd be done, and so on. So how much of the room, if you just multiply speed times time together, you get the distance that they traveled, or in this case, the amount of the room. So it is really a similar context to distance, speed, time. When we write the equation, we say, well, what do we want these two to add up to? Well, we really want the portion by the painter and the assistant to add up to one whole job. So actually, that's a pretty simple little equation. 1/4, or sorry, T over 4 plus T over 6 equals 1. Nice. What have we done? We defined our variables. We filled out the chart. We thought about the question. We built an equation, and therefore we can now use our skills, and the hard part's done. Okay. So these applications are really about taking some time to read and be careful about coming up with an equation. At this point, we know our common denominator, we multiply by it, we solve for t, and working together they can complete it in 2.4 hours. Now this is great, but again, does it make sense? Is there anything about this that you're wondering, well, I don't understand why we wrote this or that? Please start the class next day by asking questions for understanding, okay? And if there's something about the solving equations from 7.5 that bothers you, please ask about that too. It's now your turn to complete this question. Pause, think, do, and then come back and see whether you agree. Okay, first thing you should have done, you let T be the time it took to paint the room together. Andrea and Aaron, again, what's their speed? Well, they're going to work for T hours. Arandrea has got 1/3 of a room per hour. That means she'll be done T over 3 in T hours. Aaron's got a speed of 1/5 of a room per hour. So after T hours, they're done T over 5. That means that if we add these two portions together, we really want them to be done the whole room. And if you solve this question, you get 15 over 8 as your answer. So I didn't go through and show all the work, but you can definitely ask me tomorrow if that didn't make sense, okay? So it takes about 1.875 hours, all right? We will see you in class tomorrow with your critical questions. Take care.